Any integers not a fraction is divisible by 1. Integers are positive and negative numbers including 0. All whole numbers are integers. Since 0 is a whole number, 0 is also an integer. 1 divides all numbers. In fact, positive 1 and negative 1 are divisors of every integer. 1 divided by 1 is 1 or positive 1. 1 divided by negative 1 is negative 1, and 0 divided by 1 is 0. 0 has infinite divisors because all numbers with 0 as the numerator is 0, except for 0 itself because the division by 0 or 0 over 0 does not make sense. It's called undefined. This goes with all the numbers. Whenever we divide an integer with a 0, it will always be undefined. Remember, a number is divisible by a number if it can be divided equally by that number. That is, if the answer or quotient we get is a whole number. And if we try to divide 1/2 by 1, the answer will not be a whole number. Since our divisor, which is 1, is an integer, then it has 1 as its own divisor or denominator. And if we divide fractions, we have to change the operation from division to multiplication and get the reciprocal of the second fraction. In that problem, it will still be 1/1. Now, if we multiply the numerators and denominators of that two fractions, the answer must be 1/2 or 0.5, which is not a whole number. Therefore, 1/2 is not divisible by 1. Next, a number is divisible by 2 if the last digit is even. The first two items end with even digits, 0 and 8, therefore they're both divisible by 2. On the other hand, since the last two items end with odd digits, 1 and 3, these numbers are not then divisible. Let's continue. A number is divisible by 3 if the sum of the digits is divisible by 3. For example, 123,720. Let's get the sum. 1 plus 2 plus 3 plus 7 plus 2 plus 0 is equal to 15. And if we divide it by 3, the answer is 5, which is a whole number. Therefore, the original number is divisible by 3. How about this number? Let's get the sum. 2 plus 3 plus 1 plus 5 plus 4 plus 8 is equal to 23. 23 divided by 3 will give us a quotient of 7.67, which is not a whole number because it has remainders. So, the original number is not then divisible by 3. Okay, next. A number is divisible by 4 if its last two digits will give us a whole number when divided. For example, the last two digits, 20, when divided by 4 will give us a quotient of 5. So the original number is divisible by 4. However, this example, which ends with 41, when divided by 4 will give us a quotient of 10.25, which is not a whole number. So what does it mean? It simply means that the original number 951,241 is no way divisible by 4. For 5, it's very simple. The last digits must either be a 0 or a 5 to make the number divisible by 5. The first two examples are both divisible by 5 since they satisfy its divisibility rule. And how about for the last two examples? Do you think they're divisible by 5? No, they're not divisible by 5. For divisibility of 6, the number has to be both divisible by 2 and 3. Let's do the first example, which ends with an even digit, so it is divisible by 2. Now, let's get the sum of the digits to check if it's also divisible by 3. The sum is 18. And 18 divided by 3 is 6. Therefore, the original number is divisible by 6 since it has satisfied the divisibility rules of 2 and 3. How about this one? This time, let's check first if it is divisible by 3. Let's get the sum. The sum is 33, which will give us 11 when divided by 3. So, it is divisible by 3. But do you think it is also divisible by 2? Okay, it's not, because the last digit is not an even number. Though the original number is divisible by 3 but not divisible by 2 or the other way around, it won't still be divisible by 6. Okay, let's discuss a few ways on how to quickly and manually determine if the number is divisible by 7. Let's do the first process. Let's have 735. Based on the rule, we have to double the last digit, which is 5, so it will be 5 times 2, and subtract it from the remaining parts of the number, which is 73. 73 minus the product of 5 times 2, which is 10, is 63. And 63 divided by 7 is 9, a whole number. So that original number is divisible by 7. How about this one? 241. Let's repeat the process. Double the last digit, so it's gonna be 1 times 2 and subtract it from the remaining part of the number, which is 24. 24 minus the product of 1 times 2, which is 2, is 22. 22 divided by 7 is 3.14, which is not a whole number because it has remainders. Therefore, that original number is not divisible by 7. The second way to check its divisibility rule of 7 is the chica test. It was the UK-based 12-year-old Nigerian Chica Ophili. I'm not sure if I pronounce his last name correctly. Ophili discovered a new way to divide in mathematics. Chica discovered that if you take the last digit of any whole number, multiply it by 5, and then add this to the remaining part of the number, you will get a new number. If this new number is divisible by 7, then the original number is also divisible by 7. Okay, let's use our previous example 735 to apply the chica test. Now let's multiply its last digit, which is 5, so it will be 5 times 5, and add the product to the remaining part of the number, which is 73. 73 plus the product of 5 times 5, which is 25, then get the sum. That will be 98 divided by 7. It will be 14, a whole number. So the original number is divisible by 7. How about the second example we used earlier? 241. Now, let's multiply the last digit to 5. It will be 1 times 5 plus the remaining part of the number, which is 24. So it would be 24 plus the product of 1 times 5 is 5. Get the sum. It would be 29. 29 divided by 7 is 4.14. Not a whole number because it has remainders. So the original number 241 is not divisible by 7. Wait, there's more. This amazing youngest mathematician has further discovered that the test works if you start by multiplying the last digit by 12, 19, 26, and 33, and so on and so forth, and then add it to the remaining part of the number. Let's see if that really works. Yes, it does. But do you want to know the magic behind it? By analyzing the pattern, you would easily guess what number is needed to multiply to the last digit. And since the last digit is 5, the common difference of the series must be 5 as well. And since it's all about the divisibility rule of 7, the next number you have to multiply to the last digit has to have a common difference of 7. So the next digit in the series should be 40. Moving forward, a number is divisible by 8 if the last 3 digits are divisible by 8. For the first example, The last digits 104 when divided by 8 is 14. So it's divisible by 8 since it's a whole number. However, the second example is not divisible by 8 because the final answer has a remainder which is 26.25. Therefore, that original number is not divisible by 8. Divisibility rule of 9 is just like for number 3. We just need to get the sum of the digits and see if it yields a whole number quotient. For this example, the sum is 18, which is divisible by 9. So is the original number. For the second example, however, the answer has a remainder, not a whole number, because 23 over 9 is 2.56. Therefore, the original number 231,548 is not divisible by 9. For 10, it's really an easy peasy. The number has to have 0 last digit to equally divide it by 10. Hence, the first given is divisible by 10, but not the second one. Divisibility rule of 11, just like for 7, I'll also teach you some simple techniques to determine whether a number is divisible by 11 or not. Let's have the first one. Subtract the last digit from the rest of digits of the given number. Repeat this process until you find the number divisible by 11. For example, let's subtract its last digit, which is 2, from the remaining part of the number, which is 91,808. 91,806 is the difference we get in that operation. Repeat the process until we find a number divisible by 11. In this problem, it's 88. Let's try to divide 88 by 11. The answer is 8, a whole number. Therefore, the original number is divisible by 11. We can still further continue the process though. If we do so, it will be 8 minus 8, which is 0. And 0 divided by 11 is 0, which is still a whole number. If you find that technique a bit long and difficult, let me teach you an easier way to get it. It's plain and simple. Just take the alternating sum of the digits in the number, read from left to right. If the result is divisible by 11, so is the original number. For example, and if we get its alternating sum by adding and subtracting, so on and so forth, the answer must be 22, which is divisible by 11 because 22 over 11 is 2 or positive 2. So that 6-digit original number must also be divisible by 11. But what if the original number is negative? Simple. Put the alternating sum of the digits inside the parentheses and the sign outside of it. The answer must be negative 22. Multiply it to the negative sign, giving us negative 22. Then divide it by 11 to get a quotient of negative 2, which is still a whole number. Okay, last. A number is divisible by 12 if it satisfies the divisibility rules of 3 and 4. For example, let's apply the rule for 3. Let's get the sum of the digits, which is 15. And 15 divided by 3 is 5, a whole number. So it's divisible by 3. How about for divisibility rule of 4? Let's get the last two digits, which is 12. 12 divided by 4 is 3, a whole number. So it's divisible by 4. And since the number is divisible by both 3 and 4, then the original number 240,612 is divisible by 12.